Embark on a voyage of discovery with your family with Celestron's best-selling PowerSeeker Equatorial Mount telescopes. These telescopes come with everything you need to get started with astronomy, including a tripod, a finder scope, 2 eyepieces, and a Barlow lens, which triples the power of each eyepiece. The equatorial mount is a favorite of amateur astronomers because it makes it easier to track objects as they appear to move across the night sky. Choose the optical tube that's right for you, from the compact PowerSeeker 127EQ with grab-and-go convenience to the large PowerSeeker 127EQ with more light-gathering ability. Every PowerSeeker offers great views of the moon and planets. A larger model will provide more detailed views and help you enjoy fainter deep sky objects like star clusters and nebulae. When you're out under the stars, use Celestron's free Sky Portal mobile app for iOS and Android to locate objects in the night sky. Center the object in the finder scope and it's ready to view. As you observe, listen to Sky Portal's audio descriptions for the most popular objects. Happy stargazing!
This type of telescope is set up on a specific kind of mount. In fact, it's called a fork equatorial mount. So the fork, of course, refers to the 2 support tines that are actually holding the telescope itself. But the important part is the equatorial. As you'll notice, as I rotate this telescope, it's not just moving straight up and over. It's actually rotating at an angle. And that is a key feature in equatorial mounts, and it plays an important role. If you watch the sun, for instance, rising over in the east, it doesn't come straight up and it doesn't move straight over. In fact, it comes up at an arc. This telescope's mount, I should say, is tilted so that it's actually rotating parallel to the Earth's axis. If, for instance, we had an altitude azimuth mount, where the telescope just simply rises up, moves over, up and over, and you watch an object rise in the sky, you'll notice that when the object first rises, it's mostly moving in the up direction, or the altitude direction, and then it gradually moves over in the azimuth just a little bit. But then once it's pretty high in the sky, it's mostly moving in azimuth. So what this means is that as the object rises, the speed at which it changes its altitude and azimuth varies over the entire path length. So that means that you would constantly have to adjust the speed of your telescope if you tried to track an altitude and azimuth. The nice thing about an equatorial mount is that since you're tilted with the Earth's axis and it's rotating at the same rate the Earth rotates, it basically follows the objects at a constant rate. So instead of having to have a really complicated computer control to actually figure out how much to move in altitude and azimuth, you can install just a very basic clock drive in your telescope mount, and that causes it to follow objects in the sky pretty much at a perfect rate. In order to set up a mount like this, you basically just need a compass. So a lot of the bases actually have compasses built in, and so the rotation axis simply has to point to due north. So there's a point in the sky called the celestial pole where everything appears to rotate around that point. And that's where, when this telescope mount is aligned, that's where these tines will be pointing. After that, you really don't have to level the base very much. As long as these tines are pointing at that one point in the sky, this telescope will follow pretty much any object you place it on.